I'm Marky Janice Carino, and we are partner for this project.
So we are here to present our case study entitled Adapting New Production Process Layout Enhancement. What is plant layout? Plant layout is the most effective physical arrangement, either existing or in plants of industrial facilities, arrangement of machines, processing equipment, and service departments to achieve greatest coordination and efficiency of 4Ms, which considers as men, materials, machines, and methods in a plant. Plant layout it is also a design for which aims to improve the efficiency by arranging the stations according to its function. And it is also the workstations and machinery is placed or arranged by its corresponding sequence according to its similarity of workshop. Plant layout of the production company needs some methods of studies and is as a tool for evaluating the capacity of the process. WIP or WIP or work in process alignment and requirements. It is for schedule. It is for schedule data entry for faster means of production. So the layout is very important to set up in the procedures of production from the start to the end of the flow in the process. One of the major problems in the production is handling and setup of the area for accommodating some precedents of incoming new production process. In manufacturing, a process layout is a design for which aims to improve the efficiency by arranging the stations according to its function. The production line should be ideally designed to eliminate waste in material flows and management. In process layout, the workstations and machinery is placed or arranged by its corresponding sequence according to its similarity of workshop. So here are the key issues. So the company needs to study an enhancement of sub-assembly in process layout to accommodate the production target. The said study is to make changes in the production process layout to have a better and faster transaction in obtaining the achievable lead time as a precedence of the production. So as the assumptions in making a case of the methods of assembling process for the camera module comprises the following steps, which are placing the substrate on a positioning die with 90-second process time, irradiating the lens assembly with parallel rays of light that has 40-second process time, placing a lens assembly comprising the convex lens in an axial direction which 60 seconds process time, measuring the light intensity of light passing through a spot hole by means of light sensor being accommodated in a positioning the die with 30 seconds process time, determining an optimal position of the lens assembly on the basis of an obtained light intensity curve with 70 seconds process time, so determining an optimal position of the lens assembly on the basis of obtained light intensity curve with 70 seconds process time, bringing the lens assembly to the optimal axial position with 60 seconds process time, removing the positioning die and attaching an image sensor chip to the bottom surface of the substrate with 40 seconds process time, testing the camera module with 40 seconds process time, quality check of the camera module with 30 seconds process time, packing or storing the finished module with 30 seconds process time. So the challenge was to analyze the following. We have the precedence diagram, calculating the cycle time, determining the number of working stations, making a line balance, determining the efficiency. That will be discussed later on. Well, in the decision criteria, we have here the process. It describes that the process is the key points and very important matter for assembling, calculating, and analyzing the data which is needed in decision making for the project layout enhancement. When the assessment between current and proposed. In current, the process is being manually assembled in the product and unsafely handed from transportation to the next workstation. So as proposed, ways in the process, it is being arranged according to the task time in order to minimize the idle of the production. So the ways of the production. So in the people, we have here the process is basically a human activity that is one of the foundation to provide a process control, management, and maintenance for the facilities and machines. Well, in the current and proposed, in current operators are overcrowded in the facilities that cause into more contaminations to the product that is being produced. So we propose a study that people in the area is being controlled and assigned in different stations as they are divided according to its needed. Well, the layout design, a design that is provided to build a smooth flow of the process in the manufacturing area helps to lessen downtime of the production process. The current of the layout of the production area is continuous process from the start to end. So we propose a layout that in the area providing a barrier in each workstation to prevent contamination or having small particles that affects the quality of the product. Well, the method or strategy. Some methods are being used for calculating ways in making a decision, such as the assembly line balancing, numbers of stations needed, and the layout for the project. Well, in the current, the process is being continued to its steps and no. We also have SWOT analysis, which means the strengths, the weaknesses, and opportunities and threats in the production layout. So in strengths, we have here the reduces of the overhead cost of production. It increases the utilization of machines and it encourages efficient supervision and enhances flexibility in workstations and also reduces initial capital investment. While in the weaknesses, the possibilities are in high work in process inventory, the low operations and expensive material handling compared to the product layout, the requires constant inspection, high production gap, requires highly skilled operators, requires expensive machines. For other opportunities, we can provide a good quality, smooth production flow, organized process, while in the threats, the unfamiliarized of production setup, system malfunction, and unorganized flow of process.
Module within 3 months period with 9-hour shift per day and 6 days duty a week. The production itself has existing 10 different processes, so we have to study the given data to obtain lesser stations in the production area in order to save time and space in the workstation. So here in our appendices is shown the process of our camera module. With process A, 90 seconds process time, process B, 40 seconds in process time, process C is with 60 seconds in process time, and process D with 30 seconds in process time. Process E will be 70 seconds in process time. Process F will be 60 seconds process time, and process G will be 40 seconds process time, and process H will be 40 seconds process time, and process I 30 seconds process time, and process J will be 30 seconds process time. In order to achieve our goal, we have to study the assembly line balancing from the given data and follow the steps. Before we begin to solving our problems, there are a few things that we need to pay attention. First, make precedence diagram and determine the cycle time. Using the largest operation time heuristic, determine the most efficient production line. And last, determine the line efficiency and the smoothing index. So this is the first steps that we have going to do is draw the precedence diagram. We have in a table below the process time in seconds, and the predecessor. And here in the right side, we draw the precedence diagram of our process. So the second step in line balancing will be calculating the cycle time. Known the number of product is 324 units. We get the 324 units, it is per day. As we have 324 units per day, 1,944 units a week, and 7,776 a month, and 23,328 units within 3 months period. So in calculating the cycle time, we have the CT equals production time per day over number of product. So we have 32,400 seconds over 324. So the cycle time we get 100 seconds. The next step is determine the number of workstation. This is very important because in our studies, we need to provide the number of working stations to allocate those uh, production processes. So in calculating the workstations, we have NT equals sum of process time. So in the sum of process time we get here in our table, the sum of process time will be 490 seconds. So the over cycle time. So we already get the cycle time, which is 100 seconds. So NT equals 490 seconds over 100 seconds will be 4.9. And since we need the number of working stations, so we round it off into 5 working workstations. The next step, the first step will be make a line balancing. So we already here in a table the work working station, process time, idle time, and process ready. In our process 1, which is the first process, is the process A, which have the 90 seconds. So to get the idle time, we deduct the cycle time to the process time. So 100 in our cycle time deducted by the process time of 90, and the result is our idle time is 10 seconds. So the process reading will be process B and C. So we proceed to workstation number 2. We have the since to get the lesser idle time, we need to look for which is the time that takes longer seconds. So we have the process C. 100 minus 60 will be 40, and we have process B 40 seconds and equals to 0, and the process ready will be B and E. So after that, we proceed to workstation number 3, or the third working station. We have E and D, same process. We need to look for the longer process time. So 100 minus 70, the idle time is 30, and we use the 30 to be subtracted to get the lesser idle time, or it will be 0 idle time. So the time will be get used. So the process ready will be D and F. And after that, we proceed to process 4. Working station number 4. We have F and G. Same process. 100 subtracted to 60 equals the idle time is 40, and in process G we have 40, so the idle time will be 0. So in process ready will be G and H, and the last station will be H, I, and J. So same process, we have the cycle time of 100 deducted by 40, which is 60, and deducted by process I with process time of 30, and deducted with process J with 30, so it will be 0. So the process ready will be I and J. Next is the fifth step. This is the fifth step will be to calculate the efficiency. In calculating the efficiency, we have the lead time equals the cycle time over workstation equals, for the cycle time will be 100, and number of workstation is 5, so we have 500 seconds all in all. In efficiency, we have the process time over lead time. So our total process time will be 490, and our lead time we get 500, so the total efficiency is 98%. The next is index. In smoothing index, we get the square root of summation of summation of idle times squared. So here, based in our process, in the fourth process, the idle time, we get workstation 1, which is 10, workstation 2 the idle time is 0, workstation number 3 will be 0, workstation number 4 will be 0, and workstation 5 will be 0. So in our solution, we have 10 squared plus 0 plus 0 plus 0 and plus 0. And the 10, we get the square root of square we get the answer of square root of 10. So the square root of 100 will be 10, and we get the smoothing index of 10. So in our conclusion, we found out that the better idea for creating a layout design for production area is having for 5 working stations based on the result of studying the SDI. It shows assigning each task and the assembler assigned to workstation, so each has approximately same amount of work. I'm going to show you layout or proposing or recommendation design layout. So here we get the one of the company here. From the dressing room, we get the in the washing room, in the shower room, and in dusting area. And this is what we look like, what it look like. Because the camera module is critical in small particles, we need to use the air shower room or air showers that is suitable for washing both operators and materials before they enter the clean room. The ventilation system is positioned above on the side of transit area. We also use the lint roller. Lint roller is placed in the dusting area. It is used for removing dust and small particles in the factory gown. It is suitable for dust-free working environment to maintain less contamination in the area and helps the products to be keeping in safe. So after all our studies, so we have an executive summary that the plant layout is a plan of an optimum arrangement of industrial facilities including personnel, operating equipment, storage, material handling equipment, along with the sign of the best structure to contain these facilities, aim to demonstrate the tools to be used in enhancing the layout in production, especially in processing some errors and problems that need to be solved. So that's all of our case study project. Thank you.